was one of the finalist for hydrogen, which is multi-billion-dollar plant. Okay. In the end, they scrapped the idea, but I don't know whether they are reviving the idea. But small town in Illinois and small town in Texas was the two, potential sites. And they compete each other, and I don't know what happened there.
But your work would still be applicable to the CO2 capture unit in the pre and the post.
In this case, okay, so maybe possible here, okay, but again, the problem with, in this case, separating hydrogen from CO2 from hydrogen, hydrogen is smaller.
Mm-hmm.
Okay, so in this case, CO2 is smaller than nitrogen,
Okay.
so you can actually fine-tune the size so that only CO2 can go through. But in this case, hydrogen is smaller, so it's a little bit challenging here. But certainly, we can actually apply the material for air separation. Right now, this air separation, they use cryodistillation. So they boil, they liquefy first, and then they boil, okay, because, CO2, so there is boiling point difference. Okay. This is not as simple, by the way, if you might imagine. I don't know whether we have, since some of you guys are aerospace engineers, if you start changing the fuel, okay, then the turbine, combustion turbine should be different. Here, this boiler here, right, for instance, should be different from this boiler here. This boiler should be different from this boiler here, because fuel is different. In this case, basically, in oxygen is oxidizer. In this case, oxygen and nitrogen oxidizer. So it's not that simple. Again, this problem is not easy, okay, because the sheer scale is enormous, huge. It's mind-boggling. One day, they they're emitting, hundreds of tons of CO2. So scale is scary. Okay. That's why, our technology still is very, very at early stage, because the cost of the materials, you have to consider cost of the materials. You also have to, synthesize this material, tons and tons of tons. And now, and also in this case, if you start using this material for real application, then the mechanical properties also have to be measured. So it's not that easy problem that we have right now. That's why DOE has been investing a lot of money in this project.
But once you have them made, then that's it, right? So it's just a one-time, like, capital cost almost to manufacture the...
Yes, maintenance, again, that's a little bit yes and no. Okay, yes, typically, depending on the durability of these materials, you can regenerate, you can recycle it, but gradually, some of the materials will be compromised. So you still have to, add more, synthesize and add more materials. So that's long-term durability is also an issue. Okay. The other issue is that typically when you have adsorbents that like CO2, tend to like water as well. Reality is that this material, these adsorbents, will like water more than CO2. So that's also things that you have to consider. For amine adsorption-based scrubbing, presence of water is not a problem. In fact, the water is better. If you have water in the gas stream, that's better, because as I have shown you, the reaction requires water. If you have water, then this reaction can happen even better. But some of the physisorbents, if you have water, then water will kick out CO2. So that's the problem as well.
So
Any other questions?
Yeah, so realistically, it's like, so having a capture, off of these CO2 or after the off of the coal plants is 5 years out. I mean,
No, even 5 years, no.
Yeah, 10 years.
I don't think 5 years they can have a commercial plant. maybe minimum 10 years, maybe 20 years. RE is interested in investing like say early technologies. But when you take a look at the project that are supported by NETL, NETL has been supporting projects that are like a mid or long-term scale. And I happened to be at one of their meetings this summer, and the amount they're talking about building pilot plants. Okay, so they're talking about like hundreds of millions of dollars. Okay? And it's big corporation. It's not like a university type research. They have power plant company, they have process design company, they have material company, and a company like BASF. So they are making efforts. They are making serious efforts to bring this technology to market as soon as possible. But there are so many others. Policies is also a problem. Okay, we don't have carbon tax yet. I know, many of conservatives are opposing the carbon tax. But it's still, I guess, burning coal as they are is a lot cheaper right now because there's no regulation yet.
Well, when you were answering your question, were you talking about new plants coming online, or were you talking about retrofitting old ones?
Retrofitting is I believe NETL is focusing on.
Okay.
Because that's what they see most practically feasible, as opposed to building a plant like IGCC, for instance. Okay.
One question I had, I think it's kind of dumb, but
Don't ask.
when you have super small openings that you're trying to feed the gases through, I guess I kind of see it as kind of like blood through veins, and that as the CO2, preferentially absorbs to the walls, it kind of acts like cholesterol on the surfaces of the veins, and so is it possible to create
Yes,
like
that's
a
called a
blockage?
single file diffusion, right? So single file diffusion is basically if somehow the pores are linear, okay, and one-dimensional pore, and then what happens is that once you absorb, say CO2, okay, then even though we have a lot of space available, okay, if the CO2, the efficiency of this solvent is governed by how fast the CO2 is diffusing through. Okay, if the pore is one-dimensional and the pore size is uniform, and the pore size happen to be very close to the size of molecule. Okay, that's single file diffusion. That's not good. Now, most of these materials, the pores doesn't look like this. Pores are more like a small narrow window, and then we have big cavity. Okay. So as soon as CO2 goes in, and you have a lot of space over here. Okay, so CO2 can stay there for a long time, or CO2 can move to the next room. Okay, so hop. So and also these interactions are generally based on physical absorption, not chemical reaction. Okay, so CO2 will stay there, but at the same time CO2 also dissolve, and spend some time in this cavity and then move, depending on basically thermodynamics, energy, these things. Okay, so it will move to the next and just stay there. Okay, absorb, dissolve, and then move to the next. So it's not like one cavity is filled and now there's no way for the other CO2 can go through it. It's not like cholesterol. Don't worry about it. Okay, good point though. By the way, I have never been asked that question.
Oh.
So,
Yay!
aerospace engineer.
I win. All right.
Okay. Thank you very much.